Today we're going to talk about solving quadratics in the vertex form. So this form written down here, we know is the vertex form. We can identify it with the parentheses, the square. Our vertex in this case is actually going to be -7, -50. And we can find the vertex by flipping the number inside the parentheses with the x and looking at our last constant in the end. So that's going to make up our xy value of the vertex. Now in order to solve, we have to use a process of undoing. So we're trying to isolate this x variable here, and that means we need to pull all of the other terms to the other side of the equation. And how we're going to do that is we're going to undo what's happening. So for example, we have this -50 on the very end. The opposite of subtraction is addition. So in order to move the 50 to the other side of the equation, I have to add it to both sides. So I now have 50 equals 2 times x plus 7 squared. I also have this 2 out in front that I need to get rid of. The 2 is being multiplied onto the parentheses, and in order to undo multiplication, I have to use division. So I'm going to divide both sides by 2. 50 divided by 2 will give me 25. My 2's cancel on the right side, so I'm just left with x plus 7 squared. Now in order to undo a square, I need to take the square root of both sides. So the square and the square root will cancel, leaving me with just x plus 7 on the right side. And the square root of 25 is not only positive 5, but it is also negative 5, since 5 times 5 gives me 25, as well as negative 5 times negative 5. So here's where I like to split the equation up into two separate parts. I like to write positive 5 equals x plus 7, and negative 5 equals x plus 7. And now all I have to do is solve for x. So I'm going to subtract 7 from both sides. I get -2 equals x. And I also get -12 equals x. So these are my two solutions, otherwise two x-intercepts for my quadratic. And I can always double check my answer by plugging each one of these into the x value for the equation above. Now, we also have the instance that we might not be able to perfectly square root this value. And in that case, let's talk about a different problem. Okay, let's say we have this new problem. So we have 0 equals 3 times the quantity x minus 2 squared minus 72. So once again, we're trying to undo this equation. We're trying to pull all of the other variables and terms to the other side besides this x value so that we can isolate it. So our first step, we are going to add 72 to both sides of our equation. So we have 72 equals 3 times the quantity x minus 2 squared. We need to get rid of that 3 out in front. Since it's being multiplied onto that quantity x minus 2 squared, we need to divide it to be able to undo what's happening. 72 divided by 3 is going to give us 24. Our 3's cancel out, and we're just left with x minus 2 squared. Now we have to deal with that square. Once again, to undo a square, we need to square root, which means we need to take the square root of both sides. The square and the square root will cancel out, leaving us with x minus 2 on the right side. However, 24 is not a perfect square, so we need to simplify it. And what we can do is off to the side, we can write the square root of 24, and we need to break this up into two smaller terms that multiply to 24. And our goal is to try to get the largest perfect square that goes into 24. So just a reminder of some perfect squares. We have 1, 4, 9, 16, 25, 36. And I could keep counting. So the largest perfect square that goes into 24 is going to be 4. And 4 times 6 is what gives us 24. So we can break the square root of 24 up into the square root of 4 and the square root of 6. Now we can actually take the square root of 4. The square root of 4 is going to be 2. However, we can't take the square root of 6, so we're going to leave that inside our square root sign. So we can simplify the square root of 24 as 2 square roots of 6. So I'm going to go ahead and write that in my equation. However, when we square root something, we not only have a positive version of the answer, we also have a negative version of the answer. So I do need to include that plus and minus in front of my 2 square roots of 6. And now, in order to get the x variable all by itself, I have to add 2 to both sides. Unfortunately, I can't combine the two 2's because they are not like terms. So I will write my 2 out in front, and then I have the plus or minus 2 square roots of 6 equals x. And this will be my final answer. You're more than welcome to split up the 2 options. So we have 2 plus 2 square roots of 6 and 2 minus 2 square roots of 6. But the circle answer also includes both of those.